carrying on from the last video here. In the previous video, I gave you an example of where the table diagram breaks down. Well, flicking 3 coins, the table method breaks down because we can't really represent 3 coins, 3 events. This is one event. This is another. So this could be represented by the row. This could be represented by the column. But we can't really represent the 3rd coin, or if we have another coin here, we can't really represent it with the table diagram. So we would then jump to a tree diagram. So with a tree diagram, it looks like this. Okay, so you start with this coin here. You flick it. So you would start here. First coin, you would flick it. You could get a head or a tail. And suppose you get a head, you flick the 2nd coin, and then here the 3rd coin, and so on. Now, in the previous video, I asked you what is the probability of you getting all the same faces. So it would be this branch here, all tails. So 2 branches. But now I'm asking, what is the probability of getting at least 2 heads? At least, meaning, well, this would be a good outcome here, because this is at least 2 heads. Okay, so this is a good outcome. This is also a good outcome because 2 heads. Okay, this tail, this would be a bad outcome. Only 1 head. So at least 2, meaning at least 2. So this is a good outcome with 3 heads. Okay, so what is the probability of getting at least 2 heads? You see, with the tree diagram, you can ask better questions. So here, 2 heads would be this branch here. Hang on, this branch here. This is a good outcome. This is a good outcome. Okay. Oh, if I say what is the probability of getting exactly 2 heads, then this would be a bad outcome. The head. Okay, but because the question is saying at least 2, well, at least means at least. So well, anyway, so at least 2 heads would be, this is a good outcome. This is a good outcome. This would be a good outcome. And this one here. All the others are bad because all the others you only get one head or no head. Okay, so these 4 are good. So you would jump to something like this. You could get a probability of so to answer the question, what is the probability of getting at least two heads? It would be this. Get your branch first here. Get this branch first. So it would be probability heads. Okay, so it would be this. So this would be a half times a half times a half. Okay, because each branch here, this is a half probability of getting another head here. This is probability of getting a head here. So yeah, so getting h would be a half times a half times a half. Okay, and then we've got to think about probability of getting, let's say, looking at this second branch here. This second branch here would be head, tail. Okay, so we need to think about that. So it's head, and tail. Again, the probability of going down this path here would be a half, and then this also a half. Okay, so it would be, again, it would be like that. Half times a half times a half. Okay, by the way, this is 1/8. This is also 1/8. And then we need to think about probability of getting head, tail, head as well. And it turns out that this is also an 8. And then the final one, which is, well, we could get a tail and then a head and then a head. So that's the final one. Tail, head. Okay, so this is blah 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 blah. It also equals an 8. Now, remember, because we've got 4 branches that we could go down. So we could go down this branch, or this branch, or this branch here, or this branch here. So because they're or, we've got to add all the branches up. So the probability of at least 2 equals, well, we've got to add all these together. Add this, and this. So it will be an eighth plus an eighth plus an eighth plus an eighth. Okay, and well, 1, 2, 3. Well, that would be 4 over 8. Okay, which equals a half. So the probability of you getting at least 2 heads would be a half, not 0.2, not 0.5. Okay. Yeah. Oh, but by the way, if you well, you know this is a half going down this branch, a half going down here, a half going down here. Well, the probability of you going down this branch here would be 1 over 8. The probability of you going down here would be 1 over 8. The probability of you going down here would be 1 over 8. The probability of you going down here would be 1 over 8, and so on. If you add up all the branches, if you add them all up together, it comes to 1. And it makes sense. So the probability of you going down one of the branches would be 1, because you've got to go down one of the branches. Well, the point is, if you add up all the branches, it comes to 1. Just bear that in mind. Okay?